Here, we're finding the integral from 1 to 4 of secant squared of x to the negative 2 all over x cubed. So at this stage in the calculus curriculum, we really only have two clear ways of solving integrals. Either you recognize the antiderivative or you use u substitution. Here, I certainly don't just recognize the antiderivative of such a function. So this is a clear indicator that we're going to want to use u substitution. For u substitution, it's sort of unwinding the chain rule. So I want to look to see where I see a composition of functions in this expression, and the composition appears there in that numerator. And I want to let u be whatever that inside function is. So let's see what happens if we take u to be x to the negative 2. When I do so, du is negative 2 x to the negative 3 dx. Well, in my original equation, I do have x to the negative 3 dx. It's right here, because that x cubed is in the denominator. So I don't have a negative 2. So back over in my u work, I'll divide both sides by negative 2. So we get negative 1/2 du is equal to x to the negative cube dx. So that means this stuff circled in red here gets replaced with negative 1/2 du, and this x to the negative 2, it gets replaced with u. So my new integral, we have the integral, we're going to have secant squared u in the numerator. We no longer have a denominator because that x cubed got absorbed, and we have negative 1/2 du. Now the problem is, as it stands, that equality isn't true. The original integral is a definite integral. The one that I have written down below is an indefinite integral. So what we need to do is find out what our limits of integration are. Now that we're integrating with respect to u, it no longer stays as 1 and 4. So we need to figure out what u is when x is 1. So when x is equal to 1, u will be 1 to the negative 2, because u is x to the negative 2. So that tells me u is 1. So my lower limit is 1. And then for my upper limit, I like to see what happens when x is 4. When x is 4, u is 4 to the negative 2. Negative puts it down in the denominator, and that 2 squares it. So u is 1 over 16. So my upper limit is 1/16. So here we have that this is equal to the integral. That negative 1/2 is just a constant, so coefficient, we can pull it outside the integral, from 1 to 1/16 of secant squared u du. So now we have something that we can easily integrate, because now I do recognize the antiderivative of secant squared of u. That's just tangent u. So my integral is now, we can antidifferentiate, and we get that it's going to be equal to tangent of u, or negative 1/2 tangent u. Evaluate it from 1 to 1/16. So that's going to be negative 1/2 tangent of 1/16 minus negative 1/2, so that's plus 1/2, times the tangent of 1. Well, that gives me negative 1/2. I don't know what the tangent of 1/16 is. And I also don't know what the tangent of 1 is. Those are not my common angles. So this expression that we have written right here, that's our final answer.